Alright, hello, we're in the private oral exam guide. We're in Chapter 4, Airplane Systems, Section D, Gyroscopic Flight Instruments on 4-21. What instruments contain gyroscopes? The turn coordinator, the heading indicator, the altimeter, and the altitude indicator. What are two fundamental properties of a gyroscope? Rigidity in space. A gyroscope remains in a fixed position in the plane in which it is spinning. Precession. The tilting or turning of a gyro is in response to a deflective force. The reaction to this force does not occur at the point where it was applied. Rather, it occurs at a point that is 90 degrees later in the direction of rotation. The rate at which the gyro precesses is inversely proportional to the speed of the rotor and proportional to the deflective force. What are the various power sources that may be used to power a gyroscopic instrument in an airplane? In some airplanes, all the gyros are vacuum, pressure, or electrically operated. In others, vacuum or pressure systems provide the power for the heading and attitude indicators, while the electrical system provides the power for the turn coordinator. Most airplanes have at least two sources of power to ensure at least one source of bank information if one power source fails. How does a vacuum system operate? An engine-driven vacuum pump provides suction which pulls air from the instrument case. Normal pressure entering the case is directed against rotor vanes to turn the rotor gyro at high speed, much like a water wheel or turbine operates. Air is drawn into the instrument through a filter from the cockpit and eventually vented outside. Vacuum values vary between manufacturers, usually between 4.5 and 5.5 millibars of mercury, Hg, but provide rotor speeds from 8,000 to 18,000 RPM. How does the attitude indicator work? The gyro in the attitude indicator is mounted on a horizontal plane and depends upon rigidity in space for its operation. The horizon bar represents the true horizon. The bar is fixed to the gyro and remains in a horizontal plane as the airplane is pitched or banked about its lateral or longitudinal axis, indicating the attitude of the airplane relative to the true horizon. What are the limitations of an attitude indicator? The pitch and bank limits depend upon the make and model of the instrument. Limits in the banking plane are usually from 100 degrees to 110 degrees, and the pitch limits are usually from 60 to 70 degrees. If either limit is exceeded, the instrument will tumble or spill and will give incorrect indications until reset. A number of modern attitude indicators will not tumble. What are the errors of the attitude indicator? Attitude indicators are free from most errors, but depending upon the speed with which the erection system functions, there may be a slight nose-up indication during a rapid acceleration and a nose-down indication during a rapid deceleration. There is also a possibility of a small bank angle and pitch error after a 180-degree turn. These inherent errors are small and correct themselves within a minute or so after returning to straight and level flight. So the big one here is there may be a slight nose-up indication during a rapid acceleration and nose down during a rapid deceleration. How does the heading indicator operate? The operation of the heading indicator uses the principle of rigidity in space. The rotor turns in a vertical plane and the compass card is fixed to the rotor. Since the rotor remains rigid in space, the points on the card hold the same position in space relative to the vertical plane. As the instrument case and the airplane revolve around the vertical axis, the card provides clear and accurate heading information. What are the limitations of the heading indicator? The bank and pitch limits of the heading indicator vary with the particular design and make of the instrument. On some heading indicators found in light airplanes, the limits are approximately 55 degrees of pitch and 55 degrees of bank. When either of these attitude limits is exceeded, the instrument tumbles or spills and no longer gives the correct indication until reset. After spilling, it may be reset with the caging knob. Many of the modern instruments used are designed in such a manner that they will not tumble. What error is the heading indicator subject to? Because of precession, caused chiefly by friction. The heading indicator will creep or drift from a heading to which it is set. Among other factors, the amount of drift depends largely upon the condition of the instrument. The heading indicator may indicate as much as 15-degree error every hour of operation. How does the turn coordinator operate? The turn part of the instrument uses precession to indicate direction and approximate rate of turn. A gyro reacts by trying to move in reaction to the force applied, thus moving the needle or miniature aircraft in proportion to the rate of turn. The slip skid indicator is a liquid-filled tube with a ball that reacts to centrifugal force and gravity. What information does the turn coordinator provide? The turn coordinator shows the yaw and roll of the aircraft around the vertical and longitudinal axis. The miniature airplane will indicate direction of the turn as well as rate of turn. When in line with the turn index, it represents a standard rate of turn of 3 degrees per second. The inclinometer of the turn coordinator indicates the coordination of aileron and rudder. The ball indicates whether the airplane is in coordinated flight or is in a slip or skid. When aligned with the turn index, it represents standard rate turn of 3 degrees per second. All right. Number 13. What will the turn indicator indicate when the aircraft is in a skidding or a slipping turn? A slip, the ball in the tube will be on the outside. The ball in the tube will be on the inside of the turn. Not enough rate of turn for the amount of bank. Skid. The ball in the tube will be to the outside of the turn. Too much rate of turn for the amount of bank. Magnetic compass. How does the magnetic compass work? Magnetized needles fastened to a float assembly around which is mounted a compass card align themselves parallel to the Earth's lines of magnetic force. The float assembly is housed in a bowl filled with acid-free white kerosene. What limitations does the magnetic compass have? The jewel and pivot type mounting allows the float freedom to rotate and tilt up to approximately 18 degrees angle of bank. At steeper bank angles, the compass indications are erratic and unpredictable. What are the various compass errors? Oscillation error, erratic movement of the compass card caused by turbulence or rough control technique. Deviation error, due to electrical and magnetic disturbances in the aircraft. Variation error, angular differences between the true and magnetic north. Reference isogonic lines of variation. Dip errors, acceleration error. On east or west headings while accelerating, the magnetic compass shows a turn to the north. East or west headings while accelerating, the magnetic compass will show a turn to the north. When decelerating, it shows a turn to the south. Remember, ands, accelerate north, decelerate south. Accelerate north, decelerate south. Northerly turning error. The compass leads in the south half of the turn and lags in the north half of the turn. Remember unos. Undershoot north, overshoot south. Ands and unos. Alright, so we'll hold off there. That was section E, magnetic compass. That was section D and E, magnetic compass, and that's 4-25. We're going to go into F, advanced avionics. See ya.